Hi, welcome back to Lecture 4. This is Jason Baker, and let's talk about Elastic Compute Cloud, EC2. Now, the Elastic Compute Cloud service is one of the most important services within EC2. It's the service that provides compute capacity within the cloud, and it's also a service that we have already used in our course. We use EC2 to create cloud instances, which are virtual machines running on top of the Zen hypervisor. Zen is a very popular open source type 1 hypervisor that you can use to create virtual machines on a physical server. EC2 is really a building block service. It forms the core infrastructure components of many other AWS services that we'll use throughout this course. When you are deploying compute instances on EC2, there are a couple different options that you can choose from. Now, if you just go and spin up an EC2 instance like we have in earlier in this course, then you are typically selecting an on-demand deployment option. An on-demand deployment option means that you want to spin up an EC2 instance on demand, and you might run this instance for a minute, an hour, a day, a month, a year. You can run it for as long as you want to. And you're going to pay for that instance on a per second basis. Now, EC2 or AWS will bill you for this instance monthly, but when they're figuring out the utilization charges for that instance, they're you're going to pay for it on a per second basis. And when they figure out that utilization, you have to use the instance for at least 1 minute. So it's not possible to be, billed for 10 seconds of utilization. You're going to be billed for at least 1 minute worth of utilization, and then every second beyond that first minute. And on-demand instances are designed to support sort of short-term, unpredictable workloads. Uh, the in most of the workloads that I configure and practice are generally on-demand type instances, and these are instances that generally don't live that very long. In most cases, they might live at most, a week or so. Now, your second deployment option is to deploy reserved instances. And when you deploy a reserved instance, what you're doing is essentially reserving a specific amount of computing capacity for a length of time, typically at least 6 months to a year. You can even do multiple years. And the benefit of a reserved instance is that you're basically committing to using a certain amount of computing capacity for a certain amount of time. And in exchange for committing to using that capacity, AWS is going to provide you with a greatly discounted rate. So if you need to launch an EC2 instance and you know that this instance is going to run for the next year, then by all means go ahead and reserve that capacity because you'll pay substantially less. If you don't use an instance for a year, then you can apply that reserved capacity across multiple instances. For example, you might reserve an capacity for a year, but maybe you only use that capacity for 6 months with one instance, and then you spin up a new instance, and then that instance uses the reserved capacity for the remaining 6 months. So you can apply that capacity across multiple instances. And then the third deployment option is a spot deployment. And a spot deployment is really cool because it allows you to bid for computing capacity on AWS that is not currently being used by other customers. When AWS launched their EC2 service, what they realized over time was that they always had an excess amount of computing capacity available in the marketplace, and there was an opportunity to sell that excess capacity. And the way they sell it is by allowing the AWS customers to bid on that capacity, just like you're, bidding for a stock in the stock market. So you can bid for that capacity, and if your bid is accepted by AWS, then you are provided with an EC2 instance at generally a substantially reduced rate. Now, the one caveat is that if AWS ever wants that capacity back, they can shut down your instance at any time and take their capacity back. You might be thinking, well, gosh, why would I want to bid? Why would I want to deploy an EC2 instance that could be shut down at any time? Um, well, there actually are a number of different use cases for these kind of spot instances. You can imagine a use case where you need to process some data, and maybe you need to do some intense processing, but you need to process data for a very short period of time, and the probability that instance will be shut down is fairly low, or that capacity will be pulled back by AWS is pretty low. And even if AWS pulls that capacity back, you can always process that data using another spot instance. So these spot instances have become really popular over time and have almost um, created sort of like a new pattern for data processing using like fleets of spot instances. Once you've selected your EC2 deployment type, the next thing is that you need to select an EC2 instance type. The EC2 instance type basically describes the amount of computing and memory and storage I/O capacity that is going to be allocated to your cloud instance. You can think of this as like a way to properly size your cloud instance. And there are a number of different categories of EC2 instances that you can create. Anything from T2 instances to M4, M5 to C3 and C4. These different categories or instance types are designed for specific use cases. For example, T2 instance types are very low cost, very small computing instances that are primarily used for test and development purposes. We use T2 instances extensively in this course because the T2 micro instance type, it qualifies for the free tier within AWS. And T2 instances are just really cheap. In most cases, we don't need to use expensive instances for the projects in this course. In a like a typical organization deployment, oftentimes you're using either M4, M5, or C4 instances. M4, M class instances are sort of general purpose instances. I use these an awful lot for different types of applications. The C3 and C4 instances are designed for very CPU intensive applications. R3 instances are designed for memory optimized applications or use cases. So like in-memory databases or caching systems would really would run better on an R3 instance type. And then you have things like I2 instances, which are storage optimized instances that are, and these are really designed for database systems that require a significant amount of I/O. I provided a link at the bottom of this slide, and this is a great site where you can go to compare the different instance types, their features, and the current costs. By the way, the costs for an EC2 instance can vary based on the region that the instance is deployed into. For example, EC2 instances in the US East or US West regions are typically less expensive than EC2 instances in some other regions of the world, such as the Asia Pacific regions. Okay, so you've selected your EC2 instance type. The next step is to decide what type of software, what type of operating system and software should be installed on the computing instance. And the way you do that is by specifying the Amazon Machine Image, or AMI. The AMI is basically a template which defines the base operating system and applications and networking components for an EC2 instance. There are a number of different sources that you can pull from to select an AMI. Amazon provides a number of curated images. For example, the Amazon Linux AMI that we've previously used in the course is an Amazon curated image. These are images that are built and managed by Amazon. You can also uh, pull images from the broader AWS community. Other customers can create images and make those images public, and you can use those images when you create your own EC2 instances. Now, the caveat there is that you might not know what is actually in these AMIs, so you have to be very careful about using community provided images. You don't know if the person creating the image, if they use best practices and if they properly secured the image. The image might be provided by someone who's trying to harm you. So you got to be careful when using community provided images. There are also commercial images available in the Amazon marketplace. These are images provided by third-party vendors, and there's thousands and thousands of them available. You can purchase an image that has most any software application on it today, and these are images that have been designed by vendors to work properly and run their software properly within AWS. And then finally, you can create your own images, and you could create your own AMI repository. And that's something that we do. It's very, very common in industry. In my organization, we create all of our own private AMI images, and then every time we spin up a new EC2 instance, we use one of our private images to do that. And these private images are specially built to meet all of our particular requirements. One thing to note about these AMIs, about these templates, is that they only exist within a specific region. When you deploy a new EC2 instance and you select that AMI has to exist within the same region that you're deploying the instance into. You can copy an AMI from one region to another region if you want to sort of share the AMI across multiple regions. But just remember that if you're trying to spin up an instance in US West 1 and the AMI exists in US East 1, you won't be able to use that AMI because it lives within a different region. When you create an EC2 instance, you can create disk storage volumes that are attached to the EC2 instance using the elastic block storage. The elastic block storage, or EBS, is, you can think of it like a hard drive, basically. It's a volume, it's a storage volume that's attached to your EC2 instance. And these EBS volumes are a block storage device, and they are designed to support file systems, and you install your operating system on the EBS, and you can run your databases and install your software and so on. So the EBS volumes are just like hard drives. Each EBS volume that you create is replicated within the availability zone that the EC2 instance is launched into, and that replication provides high availability. If a common question that you might ask is, well, if you lose the availability zone, do you lose your data? Well, you would lose access to your elastic block storage volume if the availability zone went down. But once that availability zone came back up, then you should have access to your volume once again. And that volume is attached to the server. It's like the server is attached to a SAN, a storage area network, and the EC2 instance sees that volume as basically as a physically attached hard drive. There are a couple different EBS volume types that you can attach to your EC2 instance. The default volume type is what's called general purpose SSD, or also known as GP2. This uses a solid state drive that is very fast. The GP2 storage provides 5 nines availability, and it provides a significant a number of IOPS, which are IO, input output per second, IO operations per second. And essentially, the more IOPS, the better, the faster your storage performs. If you have like a high-end database that has to do tons and tons of transactions, you would want to make sure that database is running on storage that supports a significant number of IOPS. If the standard performance of the general purpose storage is not high enough, you can create provisioned IOPS SSD, or IO1 storage. And this provides extremely high IOPS capacity for very disk IO intensive applications. These are applications that require more than 10,000 IOPS. So very, very large, high transaction database sorts of applications. And then finally, some EC2 instance types still support the old traditional magnetic storage. This is your old traditional magnetic hard drive. This offers the cheapest storage option, but it has the lowest performance of the 3 different volume types. One of the key benefits of elastic block storage is that you can create snapshots of a storage volume. And a snapshot is a point in time copy of an EBS volume. And this copy of the volume is stored on S3. When you create a snapshot, the snapshots are incremental. So the first snapshot you'd take of a volume will take a longer period of time. But then when you do subsequent snapshots of an EBS volume, the snapshot data just contains all the incremental changes on that volume. and so the subsequent snapshots happen much faster. You pay for snapshots at S3 rates because the the data from a snapshot is stored on S3. And we use snapshots all the time. It's a great way to quickly back up data on a cloud server. You can also use snapshots to roll back any sort of system change. So if you made a change to a system and it adversely impacted the system, you could quickly roll back the system to sort of its previous state by reverting to a previous snapshot of a storage volume. One other additional storage option for EC2 instances, and these are just different certain types of EC2 instances, is something called the instance store. And the instance store is actually it's the original storage option that was available for EC2 instances when the service was first launched back in 2006. With instance data, the data for the cloud server is actually stored on the same physical server where the cloud server virtual machine is running. So it's like literally installed on the hard drives that are attached to the physical server where the virtual machine is running. This storage is what we call ephemeral, meaning that if the EC2 instance is stopped, then the data that was written to the hard drive, the data that was written to the instance store is gone forever. You can reboot the instance, that's not a problem, but if you stop the instance, then the data is gone. Well, why would you use ephemeral storage? Well, it's it's a super cheap type of storage, and it's actually pretty fast because the data doesn't have to transit over a network to a storage device. The data is actually being written directly to a hard drive on the local physical server where the EC2 instance is running. And there are cases where sort of like spot instances where you would launch an EC2 instance and maybe it's going to do some data processing and after it's done processing the data, it will store the results to an S3 bucket or something. And it doesn't need to keep a copy of the data that was written locally. The data that was written locally could just be thrown away. In that case, ephemeral storage in the instance store might make perfect sense for that sort of use case. Okay, so once you've sort of defined how your EC2 instance is going to be created, you've defined a instance type, you've defined an AMI, you have specified the storage that's going to be attached to the instance. One of the other things that you need to set up is something called a security group. A security group provides a security layer around an EC2 instance. You can think of it like a firewall in a sense. It allows you to define explicitly which IP addresses, which network addresses, which sources are able to access a server and which protocols are allowed to access a server. So it's a security group is like a very basic layer 4 network firewall system. When you create a security group, the security group has some default rules in place, and the default security group allows it allows all outbound traffic from the EC2 instance. So if the EC2 instance needs to, create a web request and access some resource out on the internet somewhere, the default security group will allow all outbound traffic from the EC2 instance, but all inbound traffic is blocked by default, which seems like a pretty sane and secure policy, right? I mean, you would want to explicitly allow certain inbound traffic to your cloud server. But if you hadn't explicitly specified which traffic is allowed into your server, you would want all traffic to be blocked by default. Now, security groups are stateful, which means that if you allow a request into your server, then the response to that request from the server is automatically allowed out, even if you haven't explicitly allowed that response out. The server is allowed to respond to valid incoming requests, and that tends to be a pretty handy feature because it means that I can allow traffic on port 80, which is the HTTP web protocol port. And if I allow traffic on port 80, then the security group will automatically allow the something like the web server, if that's running on my EC2 instance, to automatically respond back on port 80 without me having to go and explicitly define an outgoing port 80 policy on my outbound traffic rule configuration. So here's a diagram showing kind of how these security groups work. And security groups are really important in this course. And it's a concept that you'll need to understand well in order to navigate many of the assignments in the course. You'll have to understand security groups well to to get a good grade on both the midterm and the final. So this is a concept that I'll probably revisit a few times during the course because it's a concept that really trips up a lot of students. Especially students that don't have any sort of like networking background. It's difficult for them to understand kind of what's going on. So if here's an example, we have some EC2 instances, and these EC2 instances are associated with a particular security group. You can think of the security group as being this bubble that envelops the EC2 instances. It's providing that security layer. And each security group can contain any number of EC2 instances. And each EC2 instance can be associated with multiple security groups. That's actually pretty common. So I might have an instance that's in the web security group, and maybe that instance is also in the management security group. EC2 instances can be associated with up to 5 different security groups. In this example, we have the web security group, and the web security group has 3 rules in place. It allows incoming traffic from port 80 from 0.0.0.0/0. This is what we call a seeder network address. This address, where it has all zeros, basically represents the entire internet. It represents everywhere. So this first rule is saying that the security group will allow incoming network traffic on port 80 from everywhere in the world. Port 80 again is HTTP traffic. The second rule says incoming traffic is allowed on port 443 from anywhere in the world, and 443 is SSL TLS traffic. And then finally, the third rule, which is a default rule, says that outgoing traffic, so traffic that is being created by these EC2 instances, outgoing traffic is allowed out to anywhere in the world. Oftentimes in a real production environment, we would not allow traffic out to everywhere in the world. We would set up what are called egress rules. So we would explicitly specify which, what protocols are allowed out from our EC2 instances. Here's a second security group, and these instances, and this security group has these three rules. Incoming traffic is allowed from port 3306 from the web security group. Note that it's not saying from everywhere in the world, it's allowing traffic on port 3306 from instances that are associated with the web security group. When you're creating these security group rules, the source for these rules can be a network address, so it could be a specific IP address or an IP address range. It could be everywhere, like all zeros, or the source could be another security group, which is really interesting. That means that every member of the web security group can send data to the database security group over port 3306. They can also, based on the second rule, send data on port 22, which is the secure shell port. And then finally, these database servers can send data on port 80 to the web security group. So based on these ports, if the servers that are out on the internet would be blocked, would be prevented from communicating with any of these EC2 instances in the database security group. And only instances within the web security group can communicate with these database security group instances, and only on these specific ports. And that's really the power of security groups. Security groups are the kind of the main line of defense. It's the main security wrapper that's preventing communication and allowing you to explicitly define who exactly can communicate to what specific EC2 instances, and over what ports can they communicate. Okay, let's do a little bit of hands-on work with EC2. I know you have already seen and experienced the launching of an EC2 instance, but let me show you some additional things that you can do with EC2 that you probably haven't seen yet. I'm going to go to the EC2 instance dashboard in AWS. So I'll click on EC2 to get to the dashboard. And I'm going to go ahead and launch a new EC2 instance. One thing I should note about this dashboard is you see there's tons of different options and links you can click on. And this is one of the more featureful services within AWS. So there's just a ton of different features and options within this dashboard. And at first it can seem a little bit overwhelming, but over time you'll learn about what most of these features do. And so after a while it won't be as overwhelming for you. So let's start out by launching a new EC2 instance. I'm going to go ahead and click on the Launch Instance button. The first thing I need to do is select an AMI. And the set of AMIs you see here, these are curated AMIs. These are provided by Amazon. If I wanted to select something from the marketplace, I could click on the marketplace tab and I could search through thousands of different marketplace products. You can see, like, under business software, there's over 1,400 different products that are available, different developer tools, software infrastructure tools, and lots of different categories. I'm going to go back to the quick start and select the very top Amazon Linux AMI that we'll use throughout this course. I'll select the AMI. The next step is to select an instance type. And remember, the instance type defines how much CPU capacity, memory, how much I/O is going to be provided to an instance. And you can see all the different types of, uh, of, of instances that you can select. We're going to use the T2 micro instance. As you look some of these other ones, look at like a C5 18 extra large has 72 virtual CPUs and 144 gigabytes of memory. That might be an instance that you'd use for a very large database. And I don't know what the cost is of that instance, but it's probably several dollars per hour. Something like a T2 micro instance is a couple pennies per hour, so substantially cheaper. We'll go ahead and select the T2 micro instance and click Next Configure Instance Details. When I select the Configure Instance Details link, I can enable a number of different properties. I can select the number of instances that I want to create. Maybe I don't want to spin up just one EC2 instance. Maybe I want to spin up 10 EC2 instances. I could launch 10 instances that are kind of defined all the same way, and I can launch them in parallel at the same time. In this case, I just want to spin up one instance. If I wanted to request a spot instance, I could check this checkbox, and I could make a request or make a bid for a spot instance. In this case, there's no spot capacity available for the T2 micro instance, and that's pretty common for this particular instance type. It's usually there's spot capacity available for some of the larger instance types within a particular region. The network stuff, we're gonna talk about this in the next lecture, so we'll just leave the network settings at their default. I talked about earlier in the lecture, I talked about identity and access management, how you can create roles. You can apply a role to the instance when you create the instance, when you define the instance. And remember that role allows the EC2 instance to access other EC2 instances or access other AWS services as if the EC2 instance were a user. So you can apply security policies to an EC2 instance using a role, and we'll use that feature in a couple of our assignments in this course. We can enable termination protection for an instance, and termination protection means that it prevents somebody from accidentally terminating an instance. If you're working in an environment and you're running hundreds and hundreds of instances, which I am in my organization, you might have some instances which are of absolute critical importance, and you don't want somebody to accidentally delete those instances. And that could be it can actually be kind of easy to accidentally delete an instance, especially if you're looking at hundreds of them and you accidentally click on the wrong one and then select delete. It's definitely could happen. So termination protection prevents somebody from accidentally deleting an instance. And in order to delete an instance, you have to disable termination protection to terminate the instance. CloudWatch monitoring we'll talk about in a later lecture. I mentioned that you can run, there are a couple different deployment options. There are also a couple different tenancy options, and I'll talk about tenancy options later as well. By default, we're going to be running this EC2 instance in a shared tenancy model, meaning that the EC2 instance will run on the same physical servers as other customers' EC2 instances. Okay, so all of these settings look good. I'm gonna click on the next button to look at the storage settings. And the EC2 instance already has a root volume that's attached to the instance. And this root volume is 8 gigabytes of size. I can change this 8 to some other number like 10 or 100 or however many gigabytes I want that storage volume to be. And then I can select the type of storage volume. Remember, the default type is the general purpose SSD storage, also known as GP2. And here's where I can select these other storage types that I talked about earlier in the lecture. One thing to note is that I can create encrypted volumes. So I can add a new storage volume and so this is going to be a second storage volume, and I can enable encryption on that storage volume if I want encryption at rest, which is a really good feature to enable, so that the data that's stored on your EBS volume is encrypted. I just want one storage volume for now, so I'm gonna delete that second storage volume, and then click on the next button. And in this page, I can add tags to my EC2 instance. Tags is a really handy feature. Tags are essentially key value metadata that you can associate with all kinds of different AWS infrastructure resources, and we use tags uh, to associate different values and different pieces of information to our resources. One really handy tag to add to an EC2 instance is a name tag. And this allows me to give my EC2 instance a name. I'm just going to call this my server. I can add another tag, and I might want to create like a project tag. And the project tag is going to be for my development team. So so I'm just going to create my development, and I'm going to call it development project 1 or something. These tags can be whatever you want them to be, and we typically use tags as a way to sort of like categorize EC2 instances. They're really helpful for reporting purposes. Like you might want to run a report and that says, show me all of the AWS resources that are being used for a specific project or by a particular team. And so if your resources are all properly tagged, then it makes that sort of reporting really easy. I strongly encourage you to always tag whatever resources that you're creating within AWS. And you never really know how you're going to use those tags, but later on when you use them, when you need to use them, they're already going to be there. They're going to be set, and you'll be able to generate the sort of reports that you need. Okay, then I'm going to click next, and finally we need to configure a security group. And remember, the security group defines the security rules that are in place around our cloud server. Now, when I assign a security group to the EC2 instance, I have two options. I can create a new security group, and if I say create a new security group, then AWS is going to create a security group name, and it's going to kind of add a default rule. In this case, there's a default rule allowing SSH in from everywhere. Or we can also select an existing security group. So I could pick a a previous security group that I've used or that I've created, and I can assign that security group to the server. I'm just going to say create a new security group, and this particular rule is allowing incoming traffic on SSH or port 22 from everywhere. I'm going to use that security group for this demonstration. This particular security group and this rule you would never really want to use in a production setting. You would generally never want to allow incoming traffic on port 22 to your servers, because that would be a potentially very insecure security rule to have in place. I'm going to click on the review and launch button, and this gives me one more opportunity to review all my settings. You notice that AWS tells you and is giving you this warning that this security group that you're creating is open to the world. I'm going to go ahead now and launch my EC2 instance. Now, when I launch the instance, the AWS is asking me to select a key pair for the instance. And if you recall from earlier in the course, we don't use a username and password combination to access EC2 instances. We use a username and a key to access the instance. And the key pair represents your security credentials. One of the keys is installed on the EC2 instance, and the other key, the private key, is something that you store, and you store it in a safe location. And you need access to the security key in order to remotely shell into that server. If you lose your security key, then you'll basically have to terminate the server and build a new one, because you will not be able to access it without that key. You can create a new key pair, or you can choose an existing key pair, and I'm going to choose an existing key pair that I already have installed on my system, and I'm going to acknowledge that I have access to this private key. Go ahead and launch the EC2 instance. And once I do that, it tells me that the EC2 instance is now launching. If I click on my EC2, if I go back to that EC2 dashboard and look at the instances that are running by clicking on the instances link, you'll see that my instance is now launching. It's got the name I associated with the instance. It's a T2 micro type. It's launching in the US East 1 region. That's what I have specified in the AWS console. And it's running in this particular availability zone, US East 1D. It takes about a minute or so for an EC2 instance to launch up, to launch and run and be accessible. You can look at the description pane for the instance to get a lot of detailed properties for the instance. One of the most important properties is the IP address of this instance. In this case, the public IP address. This is the IP address that we're going to use to access the instance. In this case, the instance also has a public DNS address. So we could use this public DNS address to also access this instance. Okay, I'm going to go ahead and pull up my my terminal program, which is iTerm2 on the Mac, and I'm going to remotely shell into this instance using its public IP address. So I copy that public IP address and I do my SSH command, providing my security key, which is in this case the um, the it is the SCIS key, and I'm going to log in using the EC2-user as the username, and then provide my public IP address. So I do that. The first time I try to establish a connection. It's basically giving me this message saying, are you sure you want to connect to the server? You've never connected before, so we can't guarantee the authenticity of this host. I just created this host, so I believe it's the correct host. And now I've logged in, so I see the login banner from the system showing me that I've logged into an Amazon Linux based system. At this point now I can start running all kinds of different commands on the system. For example, I can do, if I wanted to do a yum update of the system to update all the system packages, I can do sudo yum update and update the packages to make sure I've applied all the latest and greatest security patches and so on. And it might take a little bit of time to do this when you do, it's kind of like doing a Windows update. When you update system packages, it can take sometimes take a minute or two. Okay, so those packages have been updated. While I'm in the logged into the system, I'm going to show you a really interesting feature that's available as part of EC2, and it's a feature called instance metadata. And instance metadata allows you to programmatically query data about the instance from within the instance. Now, this might sound a little confusing at first, but imagine that you're writing a software application, and that software application that's running on this EC2 instance needs to know some properties about the instance that it's running on. Well, it can access the properties of the instance using instance metadata. And the instance metadata is basically available via a web interface. So I can make a web request to a special IP address and URI path and pull and query data about the instance itself. So in this case, I'm going to use the curl command, which is like a command line based web browser. And I'm going to access some information about the instance. So let me copy this command and I'll paste it in and run it. So I did a curl command and hit this website. This is a special website that's internal. It's kind of like running inside the EC2 service itself and inside the virtual machine. When I do that, I get back all these different these different paths, essentially. Like this is almost kind of like a RESTful interface. So these different paths that I can hit. So I'm going to run this again and hit something like the public IPv4 endpoint. And when I do that, it responds back with the actual public IP address of the EC2 instance right there. So what's cool about this is that I can configure a software application to programmatically pull information from the EC2 instance. Okay. So EC2 instance metadata is a really handy feature. I use it all the time when I'm writing shell scripts that are running on EC2 instances because there's just a number of cases where it's very convenient for the shell script to have an understanding of the environment that it is running in. Another thing I wanted to show you real quick was the AWS CLI. There's a command that's installed by default on these AWS Linux instances, and that command is called AWS. I'm just going to run that command, and if I do like AWS help, you'll see that there are all kinds of different services that you can access using this CLI. Basically, anything that you do, any action that you take in the AWS web dashboard, any action that you do there, you can also perform using the AWS CLI, using this AWS application. And you can configure the AWS CLI with your access key credentials that you've created in IAM, and then you can run different AWS commands to, configure anything from EC2 instances to S3 buckets to databases. Just about anything you can imagine, you can do via the AWS CLI. And I use the AWS CLI quite a bit. There are times where it's just faster to do certain operations using the CLI. You can also, of course, incorporate the AWS CLI into your shell script, which means that you can programmatically build and manage and maintain all these AWS resources using software, and that allows you to automate different tasks. Let me go back over to the web dashboard, and I'll just finish up by showing you a couple other interesting features. So I'm going to go ahead and I'm going to stop my EC2 instance. Now, when I stop my EC2 instance, it basically will shut down that instance. It won't terminate it, so it won't blow away the instance and delete the data. It will just shut it down. By the way, when a EC2 instance is shut down, you no longer are paying for the CPU utilization of that instance, but you still need to pay for the elastic block storage. Any storage that is being consumed by that instance, you're going to still pay for that on a monthly basis. So just because the instance is stopped doesn't mean that the meter has stopped. You still need to pay for any storage that is consumed by that stopped instance. Okay. Now, if I look at the properties of my instance, I can look and find the volumes, the EBS volume, which is attached to my instance. I'm going to go ahead and I'm going to click on that volume. Actually, I can. There was one other thing I was going to show you before I do that. I am going to. I mentioned earlier that you can change the termination protection, and you can do that here by going into the instance settings and changing termination protection. Currently, it's disabled. If I wanted to enable it, I could enable it here, or vice versa. I could disable it if it was enabled. What I want to do is at this point is I want to create an AMI based on this instance. So let's say I've gone into this instance, I shelled into it, I've configured it, however I want to. Like I've installed whatever software I want, and I've installed the configuration of that software. And I want to use this server and its configuration as a template to create new servers in the future. I can do that by creating a new snapshot image and creating a new AMI. And I can do that by going into the actions image and say create image. And when I do that, I give the image a name. In this case, I'm just going to say my new server. I can give it a description. I'm just going to say class server, and it allows me to, it shows me the storage volumes associated with my server. So I only had one storage volume. I'm going to go ahead and create an image. And it says create an image request received, view pending image AMI. And at this point, it does a snapshot, a backup of my image or of my EBS volume. And it's going to take that snapshot now and turn it into a new AMI. Now, creating a new AMI can take a few minutes. It's got to snapshot, it's got to copy that EBS volume, and it's got to store it in S3. So it takes a little bit of time. The AMI, this AMI might take like 5 minutes or something. You can change some of the settings on your AMI. If I wanted to remove it, I would actually deregister the AMI. That basically means you're deleting the AMI. I can modify the image permissions. So for example, right now this image is private and it will only be available within my private AMI repository. But if I wanted to make this image available to the broader AWS community and to other customers, I could make the image public. Some of the images that you'll use this semester are public images that I have created for you, and I've made those images available to the public. In this case, I'm just going to keep it as a private image. Oh, this image is already ready. So the status now says available. That was pretty quick. So this image is now available. I could spin up new EC2 instances with this image if I wanted to. If I go to EC2 and if I say launch new image and click on my AMIs, there we go. We have my new server, the very top AMI. That's the AMI I just created. So I can take this configuration and use it to build additional servers in the future. So a very, very convenient and handy feature within EC2.